Hi everybody. Today we're going to learn how to reverse a singly linked list. But before we jump in and just implement the function, we need to make sure that we understand the problem fully. So let's look at an example and I'm going to explain how we are going to reverse this list. And then after looking at this example, we will implement the code. So let's start with a simple singly linked list. Our singly linked list holds data and the pointer that it's pointing to. So let's say this is a list that is going to be 1, 2, 3, and when we reverse it, it will be 3, 2, 1. And these are the pointers, so 1 points to 2, 2 next points to 3, and 3's next is null. So what we want to do is reverse the list. So the final result would be 3, 2, 1. When we look at this and we just say, okay, I'm reversing the order, it kind of seems obvious. But how will you exactly implement this? Well, in order to implement this, we need to be able to reverse our next, right? So 1's next goes to 2. So 2's next goes to 3. 3's next is null. What we want to do is 1's next would go to nothing, and 2's next would go to 1, and 3's next goes to 2. And that would end up making us have 3, 2, 1. So in order to do that, we need to be aware of our previous node so that when we go to the next node, we make that node's next the previous. So what we would do is we would keep track of 1, the head of our list. We already have this in my previous video when we implemented the singly linked list, we were keeping track of the head and the tail. So when we initiate our list, our head will be 1. And now we have to iterate through our list, but we have to keep track of our previous. So we would start off with a previous node, we'll call it prev for short, and that would be initiated as null. So that's our previous node. And we're going to iterate through our list. So we would iterate through our list and move on to our current node, and our current node we would need to flip our next. We're also going to start off with a current node. Our current node would start at our head. So we'll call this cur. So we need to iterate through our list and set our current's next to the previous node. So in the first case, when their current starts at the head, the current's next would be set to the previous. Before we do that, we need to know the next node we're going to. So we would hold a temporary variable called temp, and that would equal our original current's next, so that we know how to get to 2. Then we set our current's next to our previous node. So in this case, we're making our new list that's going to be reversed. We're setting up 1 next to point to null. And now the final piece is we need to update our previous. So now our previous becomes 1. So our previous would be set to our current. And now we go to our next piece. So we had that temp variable up here. Our current gets set to our temp. So now our current moves to 2. So now let's walk through this. 2's temp, we're going to go, our temp is equal to our current's next. So temp is going to become 3. Our current's next gets set to our previous, which means it's now going to point to 1. So we write it out here. 2's next is going to point to 1. And then our previous gets updated to our current. So our previous gets updated to 2. So now our previous is 2. Our temp is the current's next, which was 3. So now we're going to update our current to the temp. So it's going to move on to now 3. So going back to our list, our temp is going to equal our current's next. In this case, that means it's going to equal null. Our current's next is now going to be set to our previous. Our previous was 2. So 3's next goes to 2. And our previous is equal to current. So in this case, our previous becomes 3. So when we update now our current equal to our temporary, which was null, that's how we're going to know to break out of the loop. So our current is now null. We've reached the end of our list. We can break out. And if we look, we've successfully reversed our list. 3 is now the head, right? But we didn't update our head. So when we break out of the loop and we finish our reversal, we need to make sure that we update our head to, that's right, our previous, because our previous was updated to 3. This is our loops logic. And this is the final update. So we're going to take this example and apply it to the singly linked list example that I did before. We're making a new method called reverse. And I'm going to keep this right on the side while we're implementing the code. So this is the implementation of our singly linked list. This is based on a previous video that I did in my data structures and algorithms series. You can follow the link below to go to it. And I also have this code available on GitHub in my repo for the data structures and algorithm series, and that will be available in the description below. What I have done is I've added a reverse function that's going to return nothing, the void function. And I've set up our function here so that we can implement it. And we're going to look at what we've just walked through and we're going to implement that. So as I said before, this is an iterative function. We're going to go through the list, and what we need to keep track of is our previous, our current, and we have a temporary variable so that we know what to set our current to once we've updated. So the first thing then we would want to do is initialize all those data points that we need to keep track of. First, we're going to initialize our node current, and in the beginning we default this to be the head of our list. Then we also need to initialize our node previous. So this would be node P, and keep track of the previous node that we visited before. This would be null. And finally, we have our temporary node to help us keep track of what our current is supposed to be. So we can call this temp, or technically I called this temp, but we're really keeping track of our current node's next value. So we could also call it next. That is a better naming convention for this than temp. So this is a little example of just showing how you can write your code a little bit cleaner and a little more self-documenting. So we're going to call it next instead. And it is a pointer, so I'm just fixing that to be a pointer for our next. And that is also null. Remember, we're going to iterate through this list and setting our nodes next to the previous. And once we reach the end of our list, we know this because our current node is null. So we can say while current does not equal null, meaning we haven't reached the end of our list, then we want to, 1, keep track of our next pointer. So we're going to set our next equal to our current next. Then we need to set our current next to our previous. So remember, going back to the example, 1's next becomes null. And then when we move on to 2, 2's next becomes 1. So our current's next equals the previous. The next step we need to do is set our previous equal to our current so that we know which one to point to the next time, right? So we set our previous equal to our current node. And finally, we need to update our current to go to our little temporary variable that we have here that's keeping track of the next node that we need to travel to. Current equals next. So in this case, we are storing the next node we need to go to. This step here is reversing our pointers. And these two are moving our pointers ahead. The last step that we need to do is update our head. So once we fully reverse our list, remember, we need to update our head to the last previous. So our head is now equal to our previous node. We have implemented the function to reverse our singly linked list. This is an iterative implementation. When you look at this implementation, I'm calling it an iterative implementation. So the time complexity of this is O(n). And this is because we have to go through every element in our list and reverse them. We cannot skip anything. So this will always take the time of the size of the list overall. So let's test that our code works. So I have a little code example here that consists of inserting the values 1, 2, and 3 into our list. Then we're printing the list. Then we're going to reverse the list and print the list again. So we should see 1, 2, 3, and then we should see 3, 2, run. So let's see if this works. There you have it. We have 1, 2, 3, and then after successfully reversing, we have 3, 2, 1. So now you know how to reverse a singly linked list. This is actually a pretty popular question when being asked in job interviews to do either a whiteboarding exercise or to do a live coding exercise. So it is really important to understand how to solve it so that if you're asked it and you get a little nervous, you can just think back to how a singly linked list is implemented so that then you know, okay, I'm going through and I'm reversing the pointer. After understanding that, you would be able to walk through this on a whiteboard or live coding. So if you like what you saw, please remember to subscribe to my channel to get more programming tips and notifications for more videos, and happy learning.